It may be my luck that the microphone's going to be on and I was already. But I know I've had some absences today, so I want to make sure that I record. Okay. So you're 2-6. So when it comes to 2-6, you're looking at a lot of words. Okay, but you have to remember something. In theory, you have a book for this class. It is OpenStax. Nobody goes to it because you don't want to look at the syllabus, to then go to look for the book, to then click on the link, to then go there. It's a lot of effort. So what you have to remember is that I try to create your notes pages as if you needed a textbook, okay? Or you wanted a textbook. And so that's why there's a lot of words on the page, is because I am trying to supplement you going through and trying to find the textbook for the class. Okay. So when it comes to this, you are finding the equation of a tangent line, you're finding the equation of a normal line, and you are using the equation of the tangent line to find f of some value of x. That is all you're doing in this section. There is a Google form with this section, but this is all you guys are doing. That's it. There's no catch to it. This will have the advanced math feel to it. And primarily the reason why it has the advanced math feel to it is because it's very recipe-like. Step 1, step 2, step 3, maybe a step 4, and you're done. And it's every single time you see tangent line, or linearization, or linear approximation, you do this. And it's this every single time. So even though there's a lot of words, and it's terrifying because there's a lot of words on the page, essentially what you're doing is 4 steps. And if you find a normal line, you're doing maybe 5 or 6 steps, and that's it. And that's the end. And it's that way every single time. And you will find it sometimes on the multiple choice. You will find it, I'm like 95% sure you'll see it once on the free response, on a free response test. And then that's essentially it. Okay. So, and we talked a little bit about what a secant line is. We talked a little bit about it at the very beginning of the unit, which was quite a while ago. But a secant line is a line that connects 2 points together. A secant line is a fancy way of saying, hey, here's some coordinate points, write the equation of a line. I mean, you did that in IM1, you did that in IM2-ish. You for sure did in advanced math. But in the end, when you find the equation of a line, you take 2 points and you find the slope, and then you either find the y-intercept if you really want to do slope-intercept form, or you just plug it in a point-slope form and you're done. Okay, so it's pretty straightforward with secant line. It's just a fancy way of saying, hey, write the equation of a line. Here's some given points. Now, a tangent line we talked about too, because we talked about tangent lines to a circle. So if I have a tangent line to a circle, so I have my circle, and I have my radius, and my tangent line forms a 90-degree angle with my radius. Now, if I, back into the IM2 stage where you guys did geometry stuff, if I write enough equations of tangent lines, I would get the entire circle. Now, if I do a tangent line to a curve, if I do enough tangent lines, I would actually get what the shape of the curve is. So same idea. Okay. The spot at which the tangent line touches the curve is called the point of tangency. Just fancy terms. Okay. Now, to write the equation of the tangent line, you need 2 things. The slope of the tangent line, just like a regular line, and you need a coordinate point. So you need an x and a y value. If you only have an x and you don't have a y, then you have to find y by plugging it into the original equation. which we'll see later on in one of these examples. To find the equation of what's called a normal line is perpendicular to a tangent line. So the normal line kind of acts like your radius of a circle. It's perpendicular to a tangent line. Okay. All you're going to do is this. That's all you're doing. Tangent line, normal line, finding f of some point. That's it. Okay. Now, there's something below this called Newton's method, and it's dumb. You won't ever do it, but I have to tell you what it is in case you happen to see something that says, hey, use Newton's method. You're never going to use it because there's better ways of doing it than Newton's method. Okay, so we'll do some examples with tangent and normal, and then it'll make more sense, I think. Newton's method is dumb. Again, back to like job security for mathematicians. Let's find a new method for something we've already done and make it look complicated, or make it actually complicated for something that's actually very, very easy to do. Okay. Newton's method's purpose in life? To find an x-intercept. Yep. And to say exactly what that value is. Now, we have better tools. So what it does is it uses the equation of the tangent line to cross the x-axis, to make this a new coordinate point on the curve, to make a new tangent line, to cross the x-axis, to find a new point, to make an equation of a tangent line to get what C is. So, tangent line, new point, create a new tangent line, x-axis. Here's a new point, draw an equation of tangent line. Oh, look, I'm really close to C. That's my x-intercept. But it's only approximate, unless you do it enough times to get the exact. Okay, right? So, this is the equation of the tangent line, right here. And we do it enough times to get an x-intercept. We don't ever do this. Why? Because we can factor. We can use the rational root theorem, because you thought the rational root theorem was bad. This is how it works. Rational root theorem. We can use the quadratic formula. We can have a hate-hate relationship with Desmos, right? And just freaking graph it. At the end of the day, with all these equations with the tangent lines, because you're going to end up with decimals, you have to use a calculator anyways. If you're going to use a calculator anyways, you're on the calculator portion of the AP test, why wouldn't you just graph it? And use your calculator to say, x-intercept, right? So, we don't ever do this process. It's called an iterative process, iteration, because if you do it enough times, you get the exact value, but we don't ever do that. The only reason why I'm telling you this is because it could say, use Newton's method. And you're going to be like, graph. But you need to know that when it says, use Newton's method, that what you're doing is, it's a fancy way of finding an x-intercept. Actually, it's a very complicated way of finding an x-intercept. That's why I said, it's dumb. It's dumb because you use a calculator anyways. If I'm going to use a calculator, you know what I'm going to do? Freaking graph it. Like, why would I put forth the effort? Ever. Anyway. And then, back to vocabulary. Again, what are math teachers really good at? Changing the names of something for job security. If I keep changing the name, I have to teach you something, right? So, linearization, means the exact same thing as the equation of the tangent line. Why? Just because we can. Just because we can. So anytime I ask you to linearize an equation, find a linear approximation, all I'm asking for is write the equation of the tangent line. Yay! Congratulations. We changed the terminology and then nobody knows what we're talking about. Go team. Okay. So let's be clear, and I'll show you how to do a linearization one, but it's essentially the same exact thing. Anytime you see linearization or linear approximation, that means to write the equation of the tangent line.
What are you most likely to use?
Linear approximation. Good question. Yeah. Most likely on a quiz or a test, you will see write the linear approximation. I would say that on the free response, they'll ask you to find the linear approximation of something. On a multiple choice, sometimes they'll actually ask you what the equation of the tangent line is. Normally, normal lines only show up on multiple choice. They don't show up on free response typically. Because what they like to do on free response is ask you to find a linear approximation to something that's a table, not an equation. And so you have to do something that's in unit 3 in order for you to find the slope. But for now, I'll show you how to do an equation. And then you'll be like, why are we doing this? But it'll make more sense when we actually do some period science. Which won't be until next weekend. Okay. Write the equation of the tangent line. Step 1, find the derivative. And I don't necessarily, I know back in advanced math, we're like, oh, write out all the steps. I don't care. You don't have to write 1, find the derivative, and then do it. We're not at that point. If it makes you feel warm and fuzzy inside to do it that way, that's totally fine. But I don't necessarily need it. Okay, so I need y prime. What's y prime? Sin x squared. Then I need the derivative at 2, 18. I have an x value and a y value. So y prime of 2 is 9 times 2 squared, which is apparently harder than taking the derivative. 36. So then your tangent line in point slope form, y minus y1 equals m times x minus x1. So y minus 18 is equal to 36, x minus 2. I put a y of 2 because I put function notation. It's like f of 2.
Oh.
That 2 is how it's all going to end. Okay, so tangent line slope. I was trying to be mathematically correct, and now you guys are all. Alright, your tangent line slope is 36. So then the normal line slope is opposite reciprocal. Flip the fraction, flip the sign. Negative 1 over 36. Do I need you to write all these words out? No. I actually don't even need any of this part, but I just wrote it for funsies. So when I write the normal line, you probably should label, tangent line. The normal line is y minus 2 is equal to negative 1 over 36 x minus, oh wait, just kidding, y minus 18. X minus 2. I know. I'm gonna make a note to switch that.
36 up and whatever.
Yeah. I know. It's because when I did this, I just made everything numbers. Because we weren't graphing that. It didn't really matter. Okay, questions about tangent and normal? Okay, so anytime I have this, I would probably always change this to a negative exponent and then take the derivative. I'd like to avoid quotient rule if I could all love it. Especially when you're going to have to find the slope of the tangent line. And then because you have to find the slope of the tangent line, you have to simplify. And so that requires effort. So the more I can avoid quotient rule, I'm going to. Okay. Okay. Yeah. Alright, so my derivative, 2 times negative 3/4 x to the negative 7/4. So that gives me negative 3/2 x to the negative 7/4. Now I understand because I picked a stupid number. I should have picked a different number. I picked 1. It actually doesn't matter when I plug in f prime of 1. But I wanted to show you guys, make sure that you guys are aware of what your order of operations is supposed to be when you evaluate this. Because what I found is finding the derivative got really easy. Simplifying something like this got all of a sudden really hard. Okay, and it's going to get harder because you're going to be like, what am I supposed to do with this now? I totally forgot. So, obviously it doesn't really matter because it's 1. But I just want you guys to understand that technically this is 1 to the 7/4. So it's negative 3 over 2, 1 to the 7/4. Because it's in the 7/4, it's in the bottom. When you guys do these, don't get weird on me. Take the 4th root of 1 and then take it to the 7th power. Don't get weird, because if it was like 2, don't go 2 to the 7th power and then have to break it down. Okay? Because I see a lot of people like 2 times 2 times 2 times 2. Oh, let me get the number. And then, oh, I gotta break it down again. You literally just wasted like time of your life and never getting it back. So when you guys do this, try to make your life a little bit simpler because you know how like it's supposed to work. Okay. In a sense, it doesn't matter in this case because it is just 1. And so my tangent line is y minus 2 is equal to negative 3/2 x minus 1. My normal line, the only difference is I change my slope, so y minus 2 is equal to a positive 2/3 x minus 1.
And if it were a negative line, it would be x plus 1.
Yes, it was negative 1 for x, it would be x plus 1. Other questions that you guys have? And there's a theta.
Fancy zero.
It is a fancy X.
That's a fancy x. It is a fancy x. Okay. F prime of theta is equal to what? 4 cosine theta minus 1. Treat theta as if it was x. Now I'm about to ask a harder question. What's f prime of 0? What's the cosine of 0?
It's 1 or 0.
It's 1. Now, I will tell you, I personally think, and I don't care if you want to memorize the circle and then be like cosine comma theta and whatever, but I do my sine and cosine based upon the graph. Because sine is a hill in a valley and cosine looks like a V. It's up to you.
So it would be 90 is at the point that it crosses.
So 90 would have been, so this is 0, obviously. And then this would have been pi over 2, 3 pi over 2, and 2 pi.
I was thinking because it would like
1. Up to you though. Okay, tangent line, so y minus 0 is equal to 3 times x minus 0. So y is equal to 3x is my tangent. If I ask you for both on a quiz or a test, you should be able to label them so that I know which one you decided to make which one. And then your normal line would be negative 1/3 x. Not too bad.
if you don't care if the zeros are excluded or included. It's not like I need you to show me the number.
No. And the way that the majority of these things work, even on the free response, is when we get to the point that it is on a free response, you're using values of the table, and so you're not, the amount of work that you're showing is very minimal. So, you're actually going to show more work, I think, in this 100% than you would on a free response. Okay, so linear approximation. The other thing that equation and tangent lines are designed for is for approximating f of some point. And obviously, when it's a polynomial, yes, I could have taken 2.1 and find the exact value by taking 2.1 and cubing it without a calculator, and then taking 2.1 and subtracting off 2, and then adding 3 to it, and I would get the exact value. Okay. Really what this is designed for are your trig situations when they're not special triangle reference angle values. So if I wanted f of 2.1 and I had like tangent in here, nobody wants to do that without a calculator. So we use the equation of the tangent line to approximate what the exact value is. Okay? And so we will get, with the equation of the tangent line, we'll get very close to what the exact value is by plugging in 2.1 in here. But instead I'm going to use the equation of the tangent line. So anytime I have to find the linear approximation, I'm looking for the equation of the tangent line. So f prime of x is 3x squared minus 2. F prime of 2 is equal to 10. And then you're like, oh, let me write the equation of tangent line, but there's a big problem. I don't have a y value. So I need to find y by taking 2 and plugging it into my equation. So I I plug in 2 into my equation, and what do I get? 7. So my tangent line is y minus 7 is equal to 10 times x minus 2. To do my linear approximation, I'm going to change y to be L of x. Then I'm just going to move the 7 to the other side. That is my linearization equation. Because I'm supposed to use it to find f of the limit. It's notation. They're probably not docking you points if you don't do it. Because I can shortcut it in a way.
It's the same thing, just like
It is the same thing.
You only have 2 pages per story.
Okay, so I wanted f of 2.1, which is approximately the same thing as L of 2.1. So 10 times 2.1 minus 2 plus 7. I'm going to ask you to take 10 times 0.1 and add 7. And I get 8. And that's my answer. So f of 2.1 is approximately 8. That's all I'm doing. Okay. Questions? You have a Google form. You have a grade scope. And tomorrow you have another review similar to like what we did yesterday that just adds in this section into the mix. So essentially tomorrow's a work day to get stuff done. Okay. Questions that you guys have?
it doesn't ask if I normal line, you have to.
Nope. Yeah, it only asks for tangent line, you don't have to find the normal.
We also need to find
Alright, you guys have the rest of class period to work. About 7 minutes.